The applications, we start with the electronics process. This particular process will clean printed circuit boards through to electrical devices, wiring assemblies. Typically what we use is a four-stage dipping process. Stage one, we have ultrasonics in there. So the ultrasonics, as Tim has explained, gets to cleaning these parts, dissolving rosins, pastes, fluxes of electronic circuits very, very quickly. We move by robotic actions. These systems are all robotic. We move the parts through from stage one, which is the cleaner, into what we call the primary rinse, where we rinse the detergents off. We then move into a DI tank where we apply a higher frequency ultrasound, which is 132, which gives us submicron cleaning of the parts under all the very close standoff devices on the PCBs or the assemblies. And lastly, we move into what we call a thermal hot air dryer or vacuum dryer, depending on the complexities of the geometries on the parts, where the parts are dried very, very quickly. This is a fast, efficient, automated process that can be linked into any robotic lines, and information from those processes can be exported in PDF, non-editable files, on all the profile parameters of this machine. We also do a solvent version of this process as well, which is much smaller. It does exactly the same job with assemblies, but we're using halogenated solvents to clean instead of water. Some devices are very sensitive to water. This process is very simple. It's a two-stage process. Immersion one in a solvent tank, a boiling solvent, that boils about 45 degrees C. We then move automatically through an internal robot into stage two, where we rinse the parts. Up into a vapor blanket. This is a liquid gas phase where the parts go up, rinse again, heats the parts up to the 40 degrees C, and as we bring the parts through into what we call the freeboard area, which is the cold area at the top of the machine, everything flash dries instantly. So this is a very fast, efficient process for cleaning electrical devices.